Augmented Object Intelligence is a new interaction paradigm that blends rich digital interactivity into everyday objects through extended reality. What if, just as easily as we right-click a file on our computer, we could tap on a real object to show relevant information and take digital actions? Towards this, we built XR Objects, an open-source platform that detects objects in real time and uses multimodal large language models to provide information and enable digital interaction, such as asking, "What season does this grow in?" about an apple. If multiple objects are detected, users can ask questions about the entire group, such as, which of these has more vitamin C? The correct object is then highlighted in the user space. Here, while cooking, a user directly queries how long to cook their pasta for. They then set a timer and anchor it in 3D space to their pot of boiling pasta. These anchored menus and timers remain fixed in space even as the user returns from washing their hands. In addition to multi-step tasks like cooking, we believe XR objects can help with other activities like shopping, where users need to compare multiple products. XR Objects supports products with labels in any language. XR Objects also lets users anchor notes to particular objects to be discovered by others. It can also automatically detect IoT devices, such as smart speakers, and summon menus with relevant controls. First, objects in the camera stream are classified on-device using MediaPipe, producing labeled bounding boxes for each object. Using ARCore, the device localizes itself in 3D space and acquires a real-time depth map of the scene. To localize detected objects, we cast a ray from the center point of the bounding box on the device's screen towards the depth map. The hit point defines the 3D coordinates of that object. We then instantiate a multimodal large language model dedicated to this object using Pali, and provide it with a cropped image of the object to obtain important metadata, including its name, cost, and other details. The context menu is then populated and anchored to the object. Each detected object instantiates its own LLM, while a separate module handles object comparisons. In a user study comparing interactions with XR objects versus a chatbot interface, we find that users completed tasks roughly 30% faster with XR objects. Follow-up surveys also indicated that users significantly prefer an augmented object intelligence like XR objects when envisioning AI interactions with a head-mounted display. Currently, XR objects runs on a smartphone due to limited camera access on head-mounted displays. We envision a future, however, where our system runs on a headset, and XR objects can be directly interacted with, such as in this example where a user taps on a book to leave a reminder. In conclusion, we view XR objects and the augmented object intelligence it enables as a valuable step towards seamlessly blending our physical and digital realities as both AI capabilities and immersive technologies continue to advance.